Well, good evening, everybody. We're trying to get live pictures of the occultation of Mars from up in Caithness, and it's difficult to know what's going on because they're having a bit of bandwidth problems up there. So let's go and see what we can find from Caithness. Now, let me explain what's going on. Up in the north of Scotland, Mars is actually going to be going right behind the moon, and we believe that the people in Caithness have got a live feed of this, but we have to wait and see whether it happens. They seem to be having what in technical terms are called buffering problems, hence the twirly circle on the screen, and trying to live stream the feed through to everybody. There we go. That's what they are transmitting at the moment. As you can see, what we've got there, incidentally, this is reversed as it is in the sky, and the colours aren't quite all that great, but you can see Mars, that little blob there, and you can see the dark limb or edge of the moon is starting to hide Mars. Now, I suspect the picture will update every so often, and so Mars is actually going behind the moon there, and you can see the variation in size of the two. Mars is actually just about the size, it would seem, of quite a small crater on the moon, but that gives a very graphic impression of the scale of Mars compared with the moon. It's really a tiny dot, just about 12 seconds of arc across, whereas the moon is about 30 minutes of arc across, a huge difference in scale there. But that's Mars going behind the moon, as seen from pretty well live from Caithness. I can't see on the feed what time they're showing there, but that is showing that Mars is clearly going behind the moon there. And I guess it will update in a little while and maybe it will disappear entirely. From some places, and you have to be exactly on the line, Mars is right on the edge of the limb of the moon, the edge of the moon there, and it's being grazed by the moon, as it were. The Mars would actually appear to skim the mountain tops and of the craters and disappear into the depths of the craters and then suddenly reappear. Now that looks like a live image. You can see the you can see the shimmering that results from the Earth's atmosphere, and it looks to me as if Mars has disappeared on their live stream there. So that's about the time it would have happened. We don't have the sound from Caithness, so I'm not quite sure exactly what the state of play is there. We weren't expecting to get their stream, but they're panning across the moon there, and I guess it will reappear in a few minutes. So that's the start of our show. Mars disappearing behind the moon. Looks as if it's gone now. But there you've got a live view of the moon from up in Caithness, and behind the moon there is the planet Mars. I don't have the timings for Caithness for the event, which we call an occultation. Occultation meaning hiding, the hidden world of Mars in this case. Okay, perhaps we can leave that now, if I can ask to. Yep. Okay, well, we'll start our own show. And having seen Mars disappear behind the moon from Caithness, we've been able to view live stream of Mars as it is, as seen from Devon, where it's still visible. So David Strange down in Devon in the Norman Lockyer Observatory, can we go over to you and see what you've got?
Yeah, here's a live image of Mars through Ritchie Chrétien 10-inch telescope. So it hasn't disappeared behind the moon from Sidmouth. It's a rather jumpy image of Mars, a lot of clouds scudding across, so you can see it dimming quite often. At the top here, we've got the North Polar Cap. Below that, the Mare Acidalium. That's about all I can make out at the moment, but we've looks like
Oh,
we're about to lose it.
yeah. Mars being afflicted by cloud, as we're not sure where the extraneous sound is coming from that we've got here, but we've all got our microphones switched off, but there seems to be some additional sound coming in, which our technical wizard Callum will try and track down. Maybe that's the Caithness feed. I'm not sure. So you can see a little bit of detail on Mars there, can't you, David?
Yes, polar cap is now shrinking quite a bit over the last few weeks. It's springtime on Mars, but it's coming and going very badly at the moment. And of course, the moon is quite far away. Even if I scroll down, let's see if we can find the moon. What's wrong way? Moon will be the other direction. If we scroll right on down, we'll see how far the moon is.
And if anyone has got clear skies, then they look out and find the moon. There it comes in our field of view. You can see what a huge distance there is between the moon and Mars as seen from Devon. And I'm pretty sure it's cloudy where I am, and I can't exactly nip out and have a look. And also, you can see the difference in the brightness there. You've got to tune down the moon quite a lot. Mars, of course, is very distant compared with the moon, and the sunlight is very distant on Mars, so there's a difference in brightness. When we do see Mars go in front of the moon, there's quite a noticeable difference in brightness. You would have thought that Mars, being so bright as a planet, would outshine the moon, but in fact it doesn't. And that's a nice view there of the limb of the moon. So shimmering away, as we saw in Caithness, it's the same part of the moon as we saw on the Caithness occultation. So it's but from the point of view of down in Devon, it's not hidden by the moon at all. And I think we can have a look at Mars as seen from Spain as well. So maybe we could go over to Grant, who's got a telescope down in Spain. Let's have a look and see what's visible there.
So I stop share.
Sorry, Robin, I jumped ahead to Venus. So I'm on Venus now, if you'd like to see Venus.
Oh, can you show us anyway?
Yeah, I can show you anyway. Sorry, the occultation didn't happen in Spain because of the angles, so I jumped across to Venus before it disappears.
Oh, there
we go.
There's a nice image of Venus.
So this is for a 10-inch classical Cassegrain telescope, so similar to the telescope just previously shown as Mars. I'm actually live stacking this. So if I show you what it actually looks like live, so you get an impression of what, if you were looking through the telescope, it might look like, it will be a bit more blurry, a bit more wavy. You should start seeing it change now, wobble a little bit because of the seeing conditions. But when we turn on the live stacking, it cleans it all up for us and gives us
yes,
sort of an average.
So you've live stacked that image. So the individual images are more blurry than that, you're saying, and when you stack, the stacking stacks the best ones, and you get a much sharper image.
Absolutely, yeah, absolutely. It stabilizes the view for you, takes the best bits of every frame and gives you a much nicer image.
Yes,
than the wavy one. It is still live, so this is still updating constantly in the background, but it's like an average live rather than seeing every individual frame. So if
anyone thinks we've actually just taken a picture of the moon there, now that is Venus, and of course the moon is very much closer to full tonight, and Venus is a thin crescent because of the position it's in relative to the sun. And the difference, of course, also is that you don't see any craters on Venus compared with the moon, and that's because it is completely cloud covered, and we just cannot see any trace of the surface as seen from Earth, at least not in a visual way. There are ways of overcoming that by using a very sensitive infrared camera and an infrared filter, and the infrared light does actually penetrate, can penetrate from the surface of Venus. So people have been able to photograph the surface of Venus just by using an infrared camera, but it's not easy because you can only do the night side of Venus, and the bright side is actually so bright that it just overwhelms the camera. So it's a very clever technical job to filter out the bright part of Venus. Any news on what's happening in Caithness? Aha. Yes. Could we go over to the Caithness feed?
Yeah, I think Mars has just reappeared.
Yes, as I think we heard from the squeals of excitement. There it is. So it was occulted for about 4 or 5 minutes, as seen from Caithness, right up on the north coast of Scotland. So Mars did a disappearing trick. And that's a much clearer image than we were getting before. So that is rather nice to see.
It may be worth mentioning, Robin, that it's not Mars that's actually disappearing, it's the moon that is moving.
Good point, yes.
The Mars is moving only slowly across the sky. The moon moves much more quickly.
Sure.
About 24 times faster.
And had anyone been actually on that graze line, they would have been able to see that very, very graphically.
So you've got there a telescope that's tracking at sidereal rate, which is following Mars essentially, and then the moon is moving across. Mars is staying in the same place.
And while we're looking at Mars, I wonder if Grant could go back onto Mars with his telescope in Spain and get a look at that. Let us know when you've got there, please, Grant. And I should say that after this, the live streaming, we will have a talk about Mars, a very interesting talk on the history and future of Mars exploration. That's from Catherine Regan, who is in the University in the States. So just trying to remember the name of the university now. West Virginia, that's it. University of West Virginia. And so she will be giving us the latest right. We're going back to Grant in perhaps we can take the sound out from the Caithness feed now.
Sorry, Robin, just bear with me a few minutes. I was trying to get Uranus, so I'm just hopping back over to Mars. So just give me 1 minute.
And Grant's is controlling it remotely from his home in Bedfordshire, so it's quite a small target to close in on. This is why it's not just a matter of flicking a switch and the telescope zooms to Mars. It's really got to be located. Mars is only 12 seconds of arc across, compared with the moon, as I say, 30 minutes of arc across. So a very tiny feature, and you've got to find it in the in quite a large amount of sky. People think, oh yes, it's easy enough to find the objects thinking of the moon, but a small object like Mars is very much more difficult to locate, particularly when you can't just look through the telescope and see. You're relying on cameras to tell you where you are in the sky.
Share my screen.
Right.
A little bit bright. Let me just tweak around a little bit. Okay.
So no trace of the moon there. Well clear of the moon as seen from Spain. Remind us again what telescope this is, Grant?
It's a 10-inch classical Cassegrain, so quite a simple design telescope, but lots of aperture, very long focal length. It's a little bit wavy over there in Spain, but we can actually, this is through quite a large sensor, so we can increase the image scale by changing to a different sensor. It will just take me about a minute if you want to try and see it a little bit larger than that. Bear with me. Doesn't always go to plan.
So this business of having a different view of the occultation from different places, this is an example of what we call in astronomy, or in geometry indeed, parallax. So from when you're looking at a thing that is in the foreground, it appears to move as your observation point moves. It moves in respect to the background, and we use that in astronomy to measure distances. And in principle, by measuring pictures of the Mars against the moon at different times, you could measure the ratio, not the absolute distance, or you could measure the ratio of the distance of the moon and Mars. And then if you knew one, you could do the other. And that's how early astronomers worked in measuring distances in space.
It's very impressive watching Grant using flicking between one instrument and another and one camera and another. That's something denied to most of us who just stuck with one telescope and one camera, and swapping between two of them is a major task. And it's not surprising that it takes a bit of time to do that.
You just have to make sure that the object is in the center of each camera.
Yes.
If you flick through, otherwise you end up.
This is live astronomy and shows you what the problems are of just finding a planet up in the sky. It seems to be easy enough when it's all controlled, but Mars is quite a small target. Oh, we had a glimpse of it there.
It flipped through and it said, here we go. It'll be here now. I just need to change the ROI of this particular camera. And then if we go, so it's a little bit bigger than the previous camera. Let's just tweak the focus. And then we can try a different sensor if we can take it. But you can see it's wavering around a little bit. I'll turn on the live stacking feature again, but you can clearly see the ice cap there at the bottom. One of the difficulties of using a remote camera, particularly with Planetary, is knowing when you're in focus, because obviously you've got the movement of the atmosphere. So let's see what we get. It's going to go horrible before it gets better, but after a few frames, it should start coming in quite nicely.
That's very much better now.
Yes, it's getting better all the time, isn't it? When you do the live stacking.
You can see Mare Erythraeum in the top half, and Mare
There's the North Polar Cap appearing now. That's good.
In the lower half. North is at the bottom here.
Be brave and try and give you a little bit more image now.
For those of you who are watching at the start of the week, you will notice that Mars is showing a very different appearance now. The features have moved from left to right, and features that were way off the left-hand, right at the left-hand edge of the planet are now more or less in the middle. Mars's rotation period compared with the Earth, it's actually 24 hours and 37 minutes compared with the Earth's rotation. So when we look at Mars each night, it's just 37 minutes difference in its rotation. But over the period of 9 days that we've been observing, that all adds up. So we're now seeing quite a lot of different detail on Mars compared with at the start of the week, when all that darker area was way off to the left-hand side of the globe as we see it from here.
I mean, it's interesting watching it develop. Hopefully it comes across to you guys as well, that we started off with quite a rough image, quite blurry, quite noisy, and it's really cleaned up just after a minute of live capture.
And when you consider that until the video era, observers had to wait until the very stillest moment of the planets moving around and catch a glimpse and then try and make a drawing of that. Photography with film was virtually impossible to get a decent image because a film exposure was always of the order of a second or so. And you've seen how much Mars jumps around and the atmosphere smooths its image in a matter of just a few fractions of a second. So a second's exposure on film, most of the pictures were very poor, even from the biggest telescopes compared with what we can get with quite a standard amateur-sized telescope. Now let's move on by going over back to Sidmouth, where, thanks very much, Grant, where David Strange has got an image of Jupiter. And one of the most famous features on Jupiter is the Great Red Spot, and it is actually in the center of Jupiter's disk at the moment.
Yeah, have you all got that?
Yeah, we can see that now. Now you might be expected to see some. So I'm not sure who's.
Is it my audio upsetting things? Shall I turn mine off?
I think you're okay, David. I think Robin's maybe disconnected briefly, but maybe you could talk about Jupiter.
I think we've still got the Caithness. No, I've worked out what it is. It's I'm listening to the feed from Caithness.
We've got clouds scudding across now, I'm afraid. But yeah, you can see the red spot. It shrunk a bit, and it's sitting in its white spot hollow. You can certainly see a clearance around the red spot between the south equatorial belt.
Yep. You need to sort of tune your eyes into the appearance of Jupiter at the time, and the Great Red Spot is not exactly prominent at the moment in an image like this, but it is there, and it's pretty well on the central meridian, just below, as you say, the lower of the two belts there, disappearing into the cloud now. But I think it's incredible we've got any images from the UK of Jupiter or Mars at all, because the forecast has been pretty bad. So that's pretty impressive that we've got it at all.
So I'll stop sharing there now, Robin.
Yeah, okay. Thanks very much. Now we've got various things prepared for you. Now let's go back to David Arditi, who can you've got a little bit prepared for us, David, just a few images of what's coming up in the night sky over the next few days. That would be useful to look at if you can do that.
Righty-ho. This won't take long. So this is a brief summary of what's going on in the night sky in the next month. We now approaching full moon. We're just 3 days from full moon, which is on 12th of February. When we have the full moon, people often think that's the best time to look at the moon, but in fact it's about the worst time to look at the moon with a telescope, because the full moon has a washed out appearance and you don't see the shadows of the craters and the mountains. So when the moon is a smaller phase, you see the shadows of the craters and the mountains on the terminator, the line between the light and the dark side of the moon. But at full, you see this wash of light, but you do see certain features very well at full moon, like the bright rays emanating from the ray craters like Tycho and Copernicus. So then 20th February is last quarter, which will be quite a low last quarter. You'll see that moon, that waning moon in the morning sky in the east, and then the moon wanes further and we get new moon at 28th February. And new moon is the best time to look at deep sky objects. It's the best time to look for the star clusters and nebulae, galaxies, faint objects that would be washed out by a bright moon. Then 6th of March is the next first quarter moon. So the time around the beginning of March will be an excellent time to observe the moon because it will be very high in the sky. It will be around 50 degrees high, and we will see all the craters that are presented face onto the Earth. We'll see those around the first quarter. So that tends to be the best time to look at the moon with a telescope or binoculars. Then on the 5th of March, the moon goes close to the Pleiades. That will be a waxing crescent moon, about 6 days old, and it passes within a couple of degrees of the Pleiades. And you can see here the famous Pleiades star cluster, or Seven Sisters. There they are. Most people can see about 6 or 7 of them with the naked eye. And of course, with a binoculars or a telescope, you see dozens, if not hundreds, of stars in this young cluster of stars, one of the closest clusters to the solar system. And the moon, it just happens to pass it. It's close to the ecliptic, the path of the moon and the planets in the sky. This is the constellation of Taurus, and you see Jupiter is also nearby on that day, or rather the moon is close to Jupiter in early March, on the 5th of March. And this is another famous cluster here. This V-shaped cluster is the Hyades star cluster, which is a more spread out cluster than the Pleiades. And this bright star is Aldebaran, bright orange star, but very much fainter than Jupiter. Jupiter is magnitude -2.5 and Aldebaran is about magnitude +1. And the magnitude scale goes to higher numbers, higher positive numbers, as you get fainter. And there's an interesting double star in the Pleiades. I think that's called Theta Tauri, that double star, and that is a naked eye double star. But it's, I think it's 4th magnitude. So in a city, you might not see it. In a city, you may need binoculars to see that. So that's the 5th of March when the moon passes the Pleiades. Moving on to the next night, the 6th of March. And this chart is drawn for London at 7 p.m. on the 6th of March. And you see the general distribution of all the planets in the sky. In the early evening, in late February and early March, you can see Mercury is visible. It's down near the western horizon. It's only a few degrees above the horizon, but it is visible, and you might be able to find it by using Venus as a guide, because Venus will be about 5 degrees above it. Venus is now drawing closer to the sun. It's had its greatest elongation away from the sun, and over the next month it'll be rapidly getting closer to the sun. Now, following the ecliptic round, which is not shown here, but it's roughly a line going like that, you've got Uranus higher in the sky, and Uranus has already transited by the time it gets dark. It's already setting by the time it gets dark, and it's magnitude 5.8, but it's on the borderline of naked eye visibility from a very dark place. Then you've got Jupiter, which really dominates the evening sky, and on the 6th of March the moon will be close to Jupiter. Then further round you've got Mars, and in early March Mars will be at its highest point, what we call the transit point, when it's due south, as it is in this picture. It will be transiting in the early evening. It transits at 8:30 p.m. and very high in the sky indeed. It's as high as Mars can ever get from England in the sky, 64 degrees altitude. And it's getting fainter now. It's already past our position. It's rapidly retreating from the Earth. It's about 75 million miles from the Earth at the moment. By that time, it'll be getting onto 90 million miles, I should think, and it will have faded to magnitude minus 0.1, so that's close to 0 magnitude, so significantly fainter than Jupiter. And of course, it's a much different color to Jupiter. It's bright red, and it is in the constellation of the heavenly twins, Gemini, and you can see Castor and Pollux, these two stars here. The whiter of the two, brighter and the whiter of the two actually is Castor, which is a double star in a telescope, and Pollux is slightly Pollux is slightly brighter than Castor and is a more yellowish one. And here these are the bodies of the two heavenly twins, and they are straddling Mars or trapping Mars between them. And you've got other famous constellations of the winter sky shown here as well. Here is the bright star Capella in the constellation of Auriga, and that goes vertically overhead in the early evening in February and March. And then you've got, as I say, Taurus here with the Hyades cluster and the Pleiades, and also the Crab Nebula elsewhere. And below that, famous shape of Orion, with the bright variable red giant star Betelgeuse, which everybody is waiting to turn into a supernova, which could potentially be very bright if it happens. It's the closest star to the Earth that is likely to explode, but we can't predict when that will be, so it may not happen in any of our lifetimes. But keep looking at Betelgeuse. It has regular variations in brightness. It's a pulsating red giant star. And then you've got the three stars of the belt, Orion there, and below the belt you've got the Sword of Orion, which is an area of a lot of nebulosity, and you can see that nebulosity in binoculars or in a telescope, or even you get an impression of it with the naked eye. You see a misty patch with the naked eye. And then down in the lower right hand foot of Orion is Rigel, the other bright star in Orion, which is a brilliant white star, first magnitude star, and is one of the hottest, I think, one of the hottest stars known, giant star. And then following on there, you've got the brightest star in the sky. That is Sirius in Canis Major in the Great Dog. Sirius is magnitude -1, and it gets at to its highest about 8 p.m. in late February, early March. It's always seen through a lot of atmosphere, as seen from England, so it looks as if it's flashing through all the colours of the rainbow, particularly if you view it through a telescope. But that's just a property of our atmosphere. And it's a double star as well. It has a famous white dwarf companion, the Pup, but that's very difficult to see. You need a large telescope to see that. And there are lots of other interesting deep sky objects in that area of the sky. There's a cluster Messier 35, a nice telescopic cluster in in Gemini, and there is the Rosette Nebula, which is a well-known target for images in Monoceros, just to the left of Orion there, a bright glowing hydrogen nebulosity area. And the other bright star in this area of the sky is Procyon, which is the main star of the Little Dog, and that's there. So that's the sky in late March, in late February, early March. That's drawn for the 7th of March. On the 8th of March, that's the greatest elongation of Mercury. So that's when Mercury is at its furthest angular separation from the Sun, as seen by us. And it is also when it is its highest altitude in the evening sky. And on the 8th of March, it will be 10 degrees high, 30 minutes after sunset. Of course, at that time, the sky is still very bright, but it's a bright object. It's magnitude -0.2. So if you get a good western horizon, you will be able to see Mercury. And of course, Venus is a lot brighter, and you'll be able to use Venus as a guide to Mercury. And here's the square of Pegasus here, but you won't see these stars in the square of Pegasus until slightly later, maybe an hour after sunset. But I once saw Mercury from the top deck of a London bus, strangely enough, and that was quite a memorable occasion. It's quite difficult to see Mercury because it's always so low. It's elusive. It's always difficult to get a telescope onto it. So make the most of this evening apparition of Mercury, and it only will be visible for about a week either side of that date. That's your best chances of seeing Mercury. And finally, on the 9th of March, what's happening tonight, is more or less repeated one orbit of the moon later, and the moon and the Mars are very close together. And this will not be such a close approach. There won't be an occultation as seen from the British Isles, as we've seen. Exactly what you see when the moon and Mars are close together depends on where you are on the Earth. But from London, they will be separated by about 1 lunar diameter, 0.6 degrees. And then the moon will be a waxing gibbous moon, and that will be seen at 31 degrees high in Gemini. And so if you've missed it tonight, as I have, because it's been completely cloudy here, although we have seen the feed somewhat from the north of Scotland, there will be a similar performance on the 9th of March. So that's all I'll say for now. And
thank you, David.
Hope you all have clear skies.
Yes, and in fact, if I can take this theme a little bit further on into the end of March and April, there are two very important. There's one particularly important thing, which is an eclipse, a partial eclipse of the sun that will take place on the 29th of March. And there's another event happening a couple of days later, which is probably not so important, but nevertheless of great interest to a lot of observers. Anyway, the solar eclipse, we get partial eclipses about every 6 months somewhere in the world, and we're lucky enough to get one coming up on the 29th of March, which happens to be a Saturday. And what's more, it actually takes place in the mid-morning. So it's a real prime time for people to want to observe an eclipse of the sun. And what will happen is that the moon will cover the sun over to a factor of just over half. That is half of its actual diameter. Though it won't be, there's no question of seeing any detail on the edge of the sun. The sun will just appear to get a little bit dimmer. You would hardly notice unless you were told that an eclipse was taking place, even if it was a bright sunny day, because the brightness of the sun is so great. But if you can observe it safely, you will find that around with a maximum about time of about 11 o'clock in the morning, you will find that the sun has encroached about, the moon, pardon me, has encroached about 50% onto the disk of the sun. The safe way to observe it is to use the official type of dark glasses. Don't fool around with bin liners or sweet wrappers or anything like that. It really needs to be the official kind of dark glasses that you use for observing solar eclipses. Or you can, with a bit of care, use a pair of binoculars to project the image of the sun onto a piece of white card. It's perfectly easy to do. There's one risk with that, and that is to your binoculars rather than to your eyesight. And that is that if you allow the image of the sun to stray off the field of view, it might just melt the what they call the field stop, the thing that you see, which creates the circular aperture that you see, the black circular aperture when you're looking through binoculars, and that could burn. But on decently made binoculars, that's made of metal. On cheap binoculars, it's probably plastic and will frazzle straight away. So you have been warned. Be careful with if you observe using binoculars. There are other ways to do it, and look online around the time, but be safe when observing the solar eclipse. One really fun way is to use a glitter ball, and I've got one over here. Actually, I should have brought it over to show you those sort of things you have at a Christmas decoration. And if you just put that in the sun, it will put hundreds of solar images in your surroundings, and you can see the sun encroaching, the moon encroaching on the sun in that way. The other event which is taking place of limited value in terms of how many people can see it, and that is that they will have another occultation of the moon. David mentioned the moon going close to the Pleiades, but on the 1st of April, this is not a joke, on the 1st of April, the moon will actually go in front of the Pleiades at a good time in the evening. And if you're in just the right place, not only will you see the stars, some of the stars being occulted by the moon, being hidden by the moon, but there's one star in particular, which is the star Silano, which will actually have a grazing occultation like the one that they were observing up in Scotland, where it will go in and out of the valleys and behind the mountains on the moon, along the edge of the moon. And that's going to be seen across a wide swathe of southern England, going across southwestern London, up past me near High Wycombe actually, and then right through Oxford, and then on to Worcester, and then exiting the British mainland in to the north of Wales. So that's something to look out for, and you'll find details online, certainly on the Society for Popular Astronomy website, popastro.com. We'll be carrying details of that. So if you can get in just the right place, I know the Croydon Astronomical Society's observing site near Kenley is right on the path of the Greys, so they will be, I'm sure, looking out for that to happen. So now we'd like to go over to David Bennett in Bristol, not to see any live sky because he completely clouded out there, at least he was a few minutes ago. So David, you can tell us something about the Mare Crisium, which we saw live beginning of the week, but you've got a short presentation on that. Let's go over to you. Comes.
On this, and then I've got a short presentation on
Yes.
transit.
Okay, hello everybody. We wanted to talk to you briefly about one of the very interesting features on the moon, which is very easy to see. And when you know a little bit more about this feature, it's fascinating to observe it yourself in an evening through binoculars, even the naked eye, of course, and particularly with a telescope. So it's Mare Crisium that we want to talk about. And Mare Crisium, if you magnify the image of the basin, it's a most distinctive feature of the moon and located close to the eastern limb. If we could have the next slide, please. There you can see it in a bit more detail now. It is an impact basin, lunar impact basin. It's about 555 kilometers in diameter and an area that was flooded due to the impact of a large asteroid about 3.9 billion years ago, which they call the Nectarian period in the lunar terminology. It's located in the northeast quadrant of the visible side of the moon, and as it's extensive, it can easily be seen and located even with the naked eye. And if it's clear tonight where you are, you should be able to see that near the limb of the moon. The waxing and waning moon periods are more favorable for viewing, as the low-angle sunlight easily illuminates its details. Now, Mare Crisium is unlike other mares or seas on the moon in that it's completely detached. It's dark, it's smooth-looking, the floor is very smooth and has a higher boundary that shows fantastic shadows as the terminator approaches and crosses the sea or mare. Now, generally, lunar basins are named after Giovanni Roccoli, the 17th century Italian astronomer, who devised the current system of lunar naming, and Mare Crisium is also named for him. Go to the next slide, please. Now take a closer look at the many mountains scattered to the east, that's the top of this image, that make this place extremely interesting to observe or photograph at high magnification through a telescope. You can see Mons Yusov. It's a small lunar mountain located in the southeastern part of Mare Crisium, north of the Condorcet crater and northeast of the so-called Agarian promontory. It's essentially part of the mountainous rim of the Crisium Basin, but unlike other features in this area, it appears somewhat isolated because of the flooding of the basin by basalt from the sea. And the next slide, please. Now, there's a bit of lunar history, as far as we're concerned, with this part of the moon, because it was the site on the 21st of July 1969 when the Soviet probe called Lunar 15 crash landed. And that was also on the same day that 2 Apollo 11 astronauts walked on the moon. Now, a little later, the Russians launched Lunar 16, and that was able to return a sample of the lunar material from Mare Crisium and back for analysis. There was a core weighing about 170 grams that the scientists analysed, and one of the findings that they found from that analysis was that there was volcanic activity on the moon after the mare was formed. So showing the moon is a very dynamic place over geological times, and many interesting things are happening. And the final slide, please, David. And this final feature here, which you can see marked by the yellow arrow, is called the crater Picard. And it's a wonderful area to look at high magnification through a telescope. Because if you look to the right-hand side of the slide, you can see the crater in high magnification. And can you see right in the center there, there's a low circular wall. And that really is a good test of both seeing conditions and your ability in using your telescope to observe that feature and see the shadows that come from that crater and that low wall. So hopefully you have clear skies and you'll be able to see that in the not too distant future. So I'll now hand back to my colleague, David.
Thanks, Stephen. Okay, so this is a very short, very short presentation on transits in 2 particular ways. This is me in 2019 observing a transit of Mercury across the sun. And as mentioned before, safety is very important when observing the sun. So I'm not actually looking at anything through my telescope. I've got a camera attached, and that's feeding an image to a laptop and a filter as well to cut down the light. And you may not be able to see it, but on this image, Mercury is just here. And although this image may look like Jupiter, it's actually the sun with cloud scudding across, as indeed on that day it was very cloudy. And so this is a closer or zoomed in part of that image. And as you can see, I hope just there is a faint disk of Mercury as it passes over the sun. And then I think we might just be able to see a quick short video, literally a minute or so. There is some background noise, I'm afraid, but we should be able to spot Mercury where my mouse is, just there, taking on the day. And as the clouds come across, the exposure changes and Mercury becomes visible. Okay, so what's the point of showing this? Oops, okay. So
The
Robert,
next transit of Mercury, when does that take place?
the next transit, I'm not sure. I haven't checked that.
Well, I can tell you because I just looked it up. It's on the 13th of November 2032. But whether it will be visible from the UK, I don't know, because that rather depends on what time of the day it occurs. But I just thought I'd look that up for you.
Yeah, okay, thank you. I was actually going to just explain really that the transit method can be used in a slightly different way. And fortunately, my computer's playing up here. But I hope you can see from that. This is just a picture of the stars. It's about the size of the moon, 30 minutes across. And as it happens, the star in the middle there is known as Qatar 5b, and it has its own planet going around. Probably a few more as well, but we can see the largest planet of that system. And just like Mercury was passing across the face of the sun, this planet 5b, well, it's given the letter B, passes across the face of its star. So we see a similar transit. But because it's so small, the star, we can't actually image the planet or the star, but what we can do is measure the amount of light coming from the star, and a tiny amount is blocked out by the planet. Now, with Mercury blocking out light from the sun, which we saw, that is so tiny, millions of people over the world would be carrying on working as they did without even being aware that a planet was going across the face of the sun. It's just so small. With this one, it's about 1.5% light loss as the planet crosses its own star. It takes about 5 hours, and we take lots of images and measure the light, and from that we get a little dip in the light curve. And what I'm showing here on the left is the actual amount of light to scale that drops, a little nick in the light coming from the star. And on the right hand side, a detailed view of the observations made, showing the planet passing the star. So this is called transit method observing, and it's very popular and most common way of observing planets around other stars that amateurs can do.
Yeah, so that's a good example of some work that actually amateurs can achieve using what seemed to be a quite extraordinary combination of circumstances, but amateurs are actually doing that. Well, thanks very much for that. That's a really interesting thing to show what amateurs can do. I'd like to move now, thank you very much for that, over to David Strange, please, because he has been working on that image of Jupiter that he got a short while back, and we'll see how it's sharpened up, if we may. Could you stop your sharing your screen, please, in Bristol?
Okay, folks, so what I've done, I've taken a 30-second clip of Jupiter, which we were imaging a few moments ago, and I'm using a little ASI Air Plus that's got a planetary stacking routine. So here are the images all stacked. What I'm doing now is I'm going to sharpen them. I'm just going to slide this slider down, and you should see it becoming sharper.
Oh, yes.
So you can overcook it. If I do it right up, you'll see that's probably a bit too much. I can zoom in a bit. But you can see it's a very quick, easy way, not having to go through the routine of auto stack it or registacks. It's a very quick, easy way for demonstrating detail on the planet. So there you
can see the great red spot there very clearly. That's compared with what you had on the live view. That's really obvious, isn't it?
Brightness, perhaps make it a bit darker. Increase the contrast a bit. So yeah, and I think you can do the color as well, saturation. So yeah, just a very quick, easy way of stacking planets. So
thanks very much, David. That's great. And now moving on, let's Trevor has in Chichester has got a short presentation, just 3 minutes, please, on deep sky objects in Orion.
Okay, right, thank you. Oops. Yeah, what I wanted to really show is that we've seen over the last 8 days or so that there's lots of opportunity for doing different things in astronomy, whether it's a naked eye of the night sky, whether it's looking through binoculars or telescopes, whether you use cameras or not. Looking at meteors, I don't think we've discussed, but that's another opportunity. So there's lots of things that you can do. And in terms of photography as well, there's of course a plethora of people who love to take pictures of what I call nightscapes, where they just have their ordinary camera and they show some wonderful pictures of the Milky Way arcing across the sky into the sea or whatever around some object. And then there's the astro imagers who spend a lot of time getting the images. And I remember at Kellingheath, I was sitting observing through my big telescope a whole week, and I never did see the chap next door to me. And I caught him one day and I said, "Well, what are you actually doing?" And he said, "Oh, I'm taking a picture of the Crescent Nebula." I said, "Well, how many hours are you on it?" He said, "I'm trying to do 100." And he switched the camera on, went back inside and watched television every night. So, but that's what he liked, and I tend to like seeing a lot of different objects. One of the things that we've been seeing a lot this week is what we call electrically assisted astronomy viewing of the night sky. And this is a picture I took of M42, which is a very common target for beginners. And what happens, of course, with this one is that it tends to overexpose the center, as you can see there. And the way that you can get around that, if you're very careful, is you can take another picture, and this time this is at 14 seconds, and then you can merge the two together, and you come up.
We
with
can't see your shared screen at the moment. I don't think. Don't know if everybody else can, but I can't see your shared screen.
Oh, you
No, we
can't.
can't see it. No.
A second. Why is that? Sharing screen. Let's try again.
There. Now we can.
Oh, you can. Okay. Yeah. Sorry about that. Of course, I could see it. So I'll just go back a couple of pictures. So that was the one that you would have seen live. Had I been able to have done it last night, that's probably what we would have seen in Orion last night. And it tends to overexpose the center core. But to get around that, you can just take a very short period, as you see there, 4-second intervals, put those together, and when you merge the two together and do a little bit of playing, you can come out with quite a nice picture of Orion, showing the trapezium stars in the center there, not blown out, and that's all done within a few minutes on this type of imaging. And this is the Running Man Nebula. I did it on the same night. It was a wonderful night. It's about 1 o'clock in the morning. I'd started to go to bed, looked out the window, and saw it was clear as a bell. So I went out and spent a couple of hours taking these images. And this is a Running Man Nebula. I tried that earlier on, I think on Tuesday night, and I didn't get very much at all. And I spent a lot longer than 11 minutes on it, but because the transparency was very poor. And this is what you would have seen on the screen, how to be able to do it, and just sharpening up a little bit, post-processing, just a quick 5 minutes, and you can see the sort of detail you can get in really just 11 minutes of exposure time. And this is a Horsehead Nebula that would have been seen live, and processing that as well gives you a much much better view, all in, as I say, 11 minutes of exposure time. And finally, there's Jupiter. That was done on the same night, showing 3 of the moons, and also best image I've got of Mars. I've got quite a short focal length telescope, only 1.6 meters, and so it's quite small in the camera, but that's the best I can do. And so that's a quick presentation on electronically assisted astronomy and a bit of post-processing.
Yes, I must admit I'm a great fan of it. I've got even with a small telescope, one of the telescopes I have is just an 80mm refractor, really quite small. and yet just in a few seconds you can get an image of the Horsehead Nebula, and then over a period of time it brightens up, and things which I could never hope to see from my light polluted sky near High Wycombe come out in just a few seconds, as seen from seen through a telescope and a fairly up-to-date camera. But it's amazing how it happens. Now we have been trying to live stream objects all the time, and we'd like to go back to Spain now. With Grant's got Jupiter in his sights, so let's have a look at another bit of live streaming from Grant. There we go.
So this is a stack again. It's been running just in the background, sharpening up, but that is live. I can show you what the raw image at the moment looks like. So nowhere near as good, bit wavy, but the stack is looking quite nice.
And compare with David's image of Jupiter, certainly since we've been on air, you can see how the great red spot has moved because of Jupiter's very rapid rotation speed of 10 hours from a complete rotation. And that means that just in a matter of 40 minutes or so, we've seen the great red spot move from the central meridian, the center of the disk, off to one side.
Yeah, and it's surprising how often you look at Jupiter and it isn't there, which is always annoying if you're doing outreach and you want to show it off. It's always behind the back.
Can we have a look at the live view again?
Yeah.
Just see what you've magicked that out of. That's a single image, isn't it?
Yeah, I mean, it is wavering around. It's still stabilizing it for us. It's still keeping it centered, but you can see the detail coming and going. It's also a little bit, I can brighten it up a little bit, but you'll see it probably needs a bit more of a tweak on the focus at this point. It has, but you can see the effect the CN has on the live image.
Yes.
And you still see moments of really nice clarity, and that's what the stacking is doing. It's taking those nice moments of clarity and keeping those and throwing the rest away. So if we go back to the stack, you'll see the difference is quite marked.
That almost looks like magic, doesn't it? That you can get such a clear and sharp image out of something which was so fuzzy. But as I was saying earlier on, the visual observers back until certainly say before 2000, most people observed visually. It was very difficult to get this sort of image. You needed very expensive equipment. But then someone realized that with the simple webcam costing literally just a few pounds, you could actually get a video stream from a telescope, and the Pandora's box was unlocked, and we could see these amazing images from really quite small telescopes in some cases, and that is really, it would have seemed miraculous in the past. Even professional images with really large mounted top telescopes couldn't approach the detail of that. So
and of course,
it really is amazing what can be done.
And everybody now has a smartphone, and you can get some pretty reasonable results with a smartphone. It can be hard to hold it in place, so there's various things that will help you hold it in the right position. But I've seen some great images taken through smartphones of planets and the moon. I've even seen some deep sky images taken with smartphones. So it's pretty remarkable what you can do with what you already have.
Yeah, super. Now, David Strange in Sidmouth, can we have a quick last look at Mars from you? Since we've been talking about live streaming all the time, we would like to see an image of Mars, because that will lead up very nicely to our next special talk for tonight.
So
there we go.
Yeah, this is through the TAC 100. Here's the moon here, and here's the Mars. So you can see the gap is widening.
Yes.
Let's see if we can get that on a video. Now there's still Mars at the top here. Can you see that?
Yep, certainly can. You see some markings on it, yeah.
Let's go around this way. Whoops. All right. Oh, I can't find the moon. Sorry, no, we've lost the moon.
Right. Okay. Well, thanks very much for that. At least we saw Mars, and that in terms of the live streaming and our presentation, that wraps up the live streaming. And I must say, over the past 9 days, we've had some amazing sights. We started with some unprecedented views of Venus, the Moon, and Mars and Jupiter, as seen from the UK and from Cyprus. And over the last few days, we've seen a huge number of different objects, and I'd like to thank everybody, and also to Les Brand, who's not on tonight, for organising the whole thing. It's been a stupendous effort. So thanks for that. And now we have a special guest, who is Catherine Regan, who's in the University of West Virginia. And she has actually been studying Mars in a very different way. So she's going to be talking about the history of and future of Mars exploration. We've done our little bit looking at Mars through our telescopes, but I'd like to hand over to Catherine now, who's muted at the moment. I noticed. There you are. Welcome, Catherine. Over to you.
Thank you very much. I'm hoping that you can see my screen.
Yes, we can.
Oh, I can't see the right screen. Okay, fabulous. There we go. So thank you so much for asking me. So I'm Dr. Catherine Regan. I am a scientist, particularly a planetary scientist, and Mars is my special area of interest. So I've spent the last 5+ years studying Mars. So I thought I would give a very brief overview into why we spend so much of our time looking up towards Mars and what's coming next over the next decade for Mars exploration. So a bit of a brief introduction to me. So I'm currently a postdoctoral researcher. That's my job title. And what I do day to day is I research the space environment of Mars. So I look at the area of space that surrounds the planet and look at the interactions between the planet and something called plasma, which is what space is composed of, which is very highly energetic charged particles. So I research the transition between these charged particles and the planet. And I'm doing this at a university in America. So I'm at West Virginia University in the state of West Virginia and the town of Morgantown. So I've put a little pin on the map of America to show where that is. Not many people know where West Virginia is, but I moved here about 6 months ago. So I know that a lot of you have been struggling with cloudy skies in the UK this week, and I will make you feel better. And it's also been very, very cloudy here in West Virginia in particularly. But today is important for America because it's Super Bowl day. So after I finish this talk, I'm going to a Super Bowl party and really embracing the American culture. So before I moved here 6 months ago, I was based at the Millard Space Science Laboratory, which is a department of University College London. And that's where I did my PhD research. So that's where I spent just under 4 years studying Mars. And there in particular, my research was focused on dust storms on Mars. So my background here is an image of a dust storm traveling across Mars in 2018, taken by Mars Express. And I spent those 4 years researching global scale dust storms and how they impact the space environment of Mars. I'm happy to answer any questions about dust storms and what PhD is like. And when I'm not doing research, I still like to do science. I still like to talk about Mars. So I'm a very keen science communicator. I've been involved with multiple projects in the UK and now getting started with some projects here in the United States. But I'm very excited and passionate about getting other people excited about space and careers into space and making it accessible for everybody. So when I was at school, I wasn't actually in top set science. I was told I wasn't clever enough to do physics, and now I'm a physicist day to day. So I'm very passionate about showing that you don't have to be the cleverest of the clever. You just have to have a passion about space. It's a very accessible field to get into. So I'm also happy to answer any questions about career paths and what it's been like from a non-physics focused background to now being a full-time physicist. So that's a very brief introduction to me, but we're here to talk about Mars. So to start off, to introduce Mars to you, I'm going to go back a few thousand years. Now, the first instance we have any recording of the planet Mars is between 2000 and 1000 BC, and this is by the Babylonians. So the Babylonians had a record of this red object in the sky, but they didn't call it Mars. They actually called it Nergal. And this was the first instance in human history that Mars, as we know it today, has been recorded. Now, A few thousand years later, the Greeks, they also witnessed this red object in the sky, and they named it Ares. Now, both of these names, Nergal and Ares, are both named after the god of war. And we have to assume that this is because red, being the color of Mars, associated with blood and associated with war. So it's a bit of an aggressive history. But we've gone from Nergal to Ares. But the first instance of the planet being called Mars was done by the Romans around the same time. But again, being named after the god of war. So we've got this trend throughout history of seeing a red object in the sky, it being associated with war, and it being named after the gods of those types of populations across the world. Now, fast forward to kind of about 1500, 1700 AD, so a few thousand years later, our observations are getting a bit more advanced. We're not just seeing a red object in the sky and giving it name, but we're now able to make records of it. So Christian Huygens, so a very famous scientist. There's lots of scientist names that will appear in this presentation that might sound familiar. They've been honoured by having multiple missions and features named after them. But in 1659, Christian Huygens made our first drawing of Mars. Now, it's not particularly advanced. It's not as clear as the beautiful pictures we see today, even through our telescopes. But this was kind of groundbreaking, that we're seeing, this is what this planet in the sky looks like. We're seeing light and dark areas. And it's not wrong. Mars does have light and dark areas. Now, a few years later, these got a bit more advanced, so you're seeing a bit more shading in the drawing. So Giovanni Cassini was able to look at Mars as it kind of orbited on its axis and see how these features vary. So it's not just a stationary object, it's actually orbiting and changing in its features. And Huygens published in 1698 that there could be intelligent extraterrestrials out there, particularly on Mars. And this was the first recording of there potentially being Martians, which is fantastic. If you think about this, was all those years ago in 1698. Now, Sir William Herschel went forward with this idea, and he wrote that Martian inhabitants maybe enjoy a similar situation to our own. So this is not saying that there are Martians there, but they are potentially intelligent. They may have water. They have an atmosphere. There is life on Mars. Ooh. Now, not only did they speculate, all of these scientists all those years ago, about there being life on Mars, but the development of these maps and these observations drastically improved. So Richard Antley Proctor published this map in 1867 that included seas and oceans. So I'm not sure how big your screens are at home, but you might be able to see this map includes ice caps. So it's a southern and northern ice cap. Now that's correct. We know there's a south and a north pole on Mars, but there are lots of different areas of land and oceans here as well that have been named different things. The Beer Sea, I think, is quite a nice one. Laplace Land, but this is indicating that there's oceans on Mars. Now, in 1840, two fantastic scientists, Wilhelm Beer and Johann von Meidler, apologies, I'm probably pronouncing these names, mispronouncing them, but these two scientists were able to determine just through their telescope that a day on Mars, so Mars's rotational period where it spins on its own axes, is 24 hours, 37 minutes, and 22.6 seconds. Now that is only 0.1 second off the current accepted value. So we say it's 22.7 seconds. Now, to be able to do that kind of measurement in 1840 with just a telescope, I think is absolutely fantastic and such an achievement for science back in 1840. Now, a few years later, Giovanni Schiaparelli again published a more up-to-date map. So this is looking at more of the kind of geological features, these darker and these lighter areas, and these different kind of links between these areas. And again, there's a north and south cap. But this was a really, really important map in terms of the history of Mars exploration. Now, this is because just a few years before, in 1869, the Suez Canal opened. And that was, at the time, the feat of human engineering. We had never been able to do anything so huge and so major as to open this huge canal that opened up transportation links across the world. And this was as good as human engineering can get. Now, going back to this map, I'm not sure if you can tell, but he labeled these lines going between these light and dark areas canali. Now, unfortunately, Google Translate didn't exist back then. So canali was mistranslated, as being canals. The actual translation of canali is channels. So Schiaparelli indicated there were these channels connecting different areas on Mars. But this translation of canals sent the world into frenzy, because if humans have only just managed to make canals on Earth, then what are these Martians like if they've been able to put canals on Mars for all of these years? Now, thankfully, this translation was resolved. It did take a few months for word to reach because we didn't have social media and things like that, so it all had to be done by letters. But this kick-started a whole new area of science, in particularly the world of science fiction. So if there was life on Mars, then what could that mean for the world today? So, I mean, there is so much Martian science fiction to choose from for this slide, but I've chosen a few of my favorites, as well as a kind of selection from different books, TV programs, movies, video games. My particular favorites is Doctor Who. I'm a huge Doctor Who fan, although The Waters of Mars is a particularly scary episode. Futurama, the film The Martian. Lots of people ask me my judgment on The Martian as a Mars scientist, and bit of a spoiler alert, I think it's a fantastic film. It's one of my favorites, apart from the fact that Matt Damon should maybe die quite a few times, but it is very, very good. Now, some of you that are eager-eyed might notice that I've missed one particular type of science fiction on here, arguably the most famous Martian science fiction there is. Unfortunately, I can't hear what you're saying, but I'm hoping you're screaming at the screens, War of the Worlds. So H.G. Wells' War of the Worlds, I think, is the most famous Martian piece of science fiction. It has been made into so many different films, TV programs, games, that I actually couldn't fit them all onto this slide. But again, here's a selection of them. Jeff Wayne's musical version of War of the Worlds is absolutely fantastic. I've seen it twice. If you get a chance to go and see it, I really, really would. It's phenomenal. And there's a very weird coincidence between me and War of the Worlds, because when I was doing my PhD at the Millard Space Science Laboratory, I was living with my family nearby in a little village outside the town of Woking. In particular, it was the town of Horsell. Now, the aliens actually land on Horsell Common in War of the Worlds, which I had no idea before moving there. So in Woking Town Centre, we actually have a giant Martian statue. So if I believed in fate, I would say that was a sign telling me that to research Mars was kind of destined for me. So that is science fiction. But if we go forward to 1957, science fiction became very, very real with the launch of Sputnik. So Sputnik launched the space race, and it launched lots of different geopolitical agendas across the world. But the space race really was phenomenal. I wish I'd experienced it, not for the politics, but just for the excitement of having something new happening in space every single day. Now, I feel like most people are very familiar with Apollo and the race to the moon, but what was happening alongside of the race to the moon was the race to Mars. So in 1964, the first mission to ever go to Mars was successful. This was a NASA mission. It was called Mariner 4, and it just did a flyby. So it just launched towards Mars. It didn't try and get into orbit, but it just flew past. And very cleverly, the scientists put on a camera, and they managed to get the first ever photograph taken of Mars from space. Now, I have this photograph for you, so brace yourselves. It's not that great. We are spoiled nowadays. We have so many fantastic, beautiful images of Mars. But if you go back to 1964, we'd never seen the red planet up close before. So this is still super, super exciting. Now, just a few years later, in 1971, NASA did manage to get an orbiter to stay around Mars. So it didn't just fly past, it stayed in orbit and managed to collect some great images and do some great science. That was the Mariner 9 mission. And then just 5 years later, so if you think about the technological advancements in those 5 years, they managed to send the first lander onto the surface. So Viking 1 was the first lander. It didn't have wheels, it wasn't a rover, it stayed in the same position, but we still used data from the Viking landers about the Martian atmosphere, about the composition, about what's going on the surface. So these brought us back some fantastic bits of data that we still use today. Now we have a whole selection of landers, rovers, satellites. There's a lot going on at Mars, and it's not just NASA. We have contributions from countries all over the world that all work together to help us answer some of the fundamental questions about the red planet. Here's the location of all of the landers that have got there. So we have got all of these landers. I will say all but one are from NASA. So there's a big gap in the market for other countries to contribute here. But the Tianwen-1 rover was the Chinese Space Agency's rover that landed in 2021. So now only 2 of these rovers are still operational, rovers or landers. So the Perseverance rover up in Jezero Crater is still going. That also landed in 2021. And then the Curiosity rover, which landed in 2012, is also still there as well. So we've got lots of assets, not only in orbit around Mars, but on the surface that are helping us to collect data and collect information for us scientists to work on. So going back to 1659, we have come a very, very long way from what arguably is a few squiggles in a circle to the falsely translated canals, to telescopic views from Hubble, and then views from our satellites, Mars Global Surveyor. So this is a fantastic figure that I did steal. But 2002 was quite a while ago. So I thought I would share the kind of latest global image we have of Mars. That is also my favorite photograph. It's the background on my phone. And that is this global image that was taken by the European Space Agency's Mars Express mission. Now, Mars Express has been in orbit around Mars for over 20 Earth years, and in 2023, it celebrated its 20-year anniversary and released this image, which is phenomenal. I could look at this for hours. A fantastic view. So if you go back to 1659, we've gone from a squiggle to this extremely high definition image. Absolutely fantastic. Okay, so what do we have currently operating on Mars? So I mentioned we have our 2 rovers, Perseverance and Curiosity, on the surface, still collecting data. They're sending data back right now for us to do work on. But then if we go into orbit, the current operational satellites that we have are an amalgamation of satellites from different countries. So we have the ExoMars Trace Gas Orbiter and Mars Express on each side of the slide. There are European Space Agency assets. We have Odyssey, Maven, and Mars Reconnaissance Orbiter, which are NASA satellites. And then we also have 2 satellites from other countries. So Tianwen-1 is our Chinese Space Agency satellite. And then we have HOPE, that is our satellite from the United Arab Emirates. So it's a huge collaboration across the world to try and understand this red planet, which is great. But I'm going to talk about just one of these current operations. So Mars Express is one of my favorites. I have to say one of, because it's very, very difficult to choose. But I spent my PhD using data from this satellite. And I mentioned it's been in orbit around Mars for over 20 years. So what does that look like in terms of numbers? So that's over 24,000 orbits around Mars. Now, 20 Earth years in orbit is around 10.3 Mars years. That's obviously a lot higher now because this was in 2023. It's helped communicate with 12 of our rovers and landers and other satellites on the surface. So working with these other space agencies to help bring this data back to Earth. There's been over 170 PhD students trained, including me. I'm very happy to be included in that. It was the European Space Agency's first mission to orbit Mars. And it wasn't just the first mission to orbit Mars, it was the first mission of the European Space Agency to orbit any other planet. So that was super, super exciting. And although this is now a relatively old mission, the science is still set to continue until at least 2026. So we're still there, we're still operating, and we're still doing fantastic science with Mars Express. Now, a zoom in of the global photo that I showed you a few slides ago, you might have been wondering why we're seeing all these different colors, because you think Mars is just red, right? But here you're seeing different oranges, you're seeing some blues, potentially even some greens. And this is because this image was able to put true colors over the different clouds and the different geological deposits that were happening on Mars. So this zoom in is on Valles Marineris, which is this huge canyon kind of crack across the surface of Mars. And this bluey green color is haze. So inside this canyon, we've got some cloudy haze going on, which is giving these beautiful colors. And then we've got some dark deposits at the top, which are sulfate deposits. So even though this is not an asset on the ground, we're still able to do kind of atmospheric and geological investigations from orbit, which is absolutely fantastic. And you can zoom in any area from this global image and see in really, really high resolution the different craters and the different types of geology that's going on in the craters, and see some of the clouds as well. So we've been studying Mars for a very, very long time. What do we know? What are the things that we've learned? So we know it's roughly half the size of Earth. The gravity is around 1/3 of what we have here on Earth. So whatever you weigh here, you would weigh 1/3 of that on Mars. It's about 1.5 times the distance from the sun. So if you picture the distance from the sun to Earth as being 1, you do another half in addition to that. That's about where Mars is. Mars has 2 different moons called Phobos and Deimos. Now they're really, really interesting and worthy of their own talk, but they are not spherical. They're kind of weird, different shapes. And one of them is actually moving so close to Mars that we think it's actually going to collide with the planet eventually. Now, Mars is very, very cold. The average temperature is about -70 degrees Celsius. It can, on very, very extreme days, get up to about 30 degrees, but it can also go all the way down to -130 degrees. So it's not a particularly nice place to want to go. The year is about twice an Earth year, so it's 687 Earth days to go around the sun once. So although the year is twice as long, the day is only 37 minutes longer. Now, it's a common misconception that Mars doesn't have an atmosphere. It does. It's just extremely thin. That's why we can still get clouds, but it's about 1% of the density of our atmosphere. And we know, looking back geologically, that there was water on the surface of Mars. We can't see any liquid water at the moment. We can see ice and we can see water vapor. So we can see the 2 other forms, but we can't see any liquid water. So that's one of the open questions of where did the water go? And one of the big differences that is linked to my research is that Mars has no magnetic field. So at Earth, we're very, very lucky. The movement inside of Earth, of the magnetic material, provides this huge magnetic field that encompasses us, and is almost like an invisible force field that protects us from the really harmful radiation that comes from the sun. Now, Mars does not have that. And we know from looking at the rocks that 4 billion years ago, it did have that. So what happened to that? Why is it gone? What does that mean? Could that happen to us? We don't know. So I've kind of given these questions away just by talking. We really want to know what happened to the magnetic field. Why did that disappear? How did that disappear? Could that happen to us? Now, the atmosphere is only 1% of our Earth's atmosphere, but we think that if you go back to when Mars did have a global field, that the atmosphere was just as thick. So it's lost all of its atmosphere, but is it still losing its atmosphere? Do the rates change? Does it lose all of the atmosphere at once, or did it happen slowly over time? That's what we want to find out. And we also want to see if there's any liquid water, because we know on Earth, where there's water, there tends to be life not very far behind. So if that's the case on Mars, if there was water at one point, could Mars once have had life on it? Can we see signs of this life? So although we have learned so much about this red planet, there are still so many more questions we want to find out. So in order to do this, we're going to continue working with all of our operational rovers and our operational satellites. But what's the harm in sending a few more things out there? So here is a selection of the future missions that we have to Mars. So I'll go in order of time. So this year, we have the launch of the Escapade mission, which I'll talk a little bit more about in just a moment. But then next year, we have the Martian Moon Explorer. So technically, this is mainly going to look at Phobos and Deimos, the 2 moons, but it also will do some really cool science about Mars whilst it's there. So this is a Japanese mission. We then have the Rosalind Franklin rover, which will be launching in 2028. This is a European Space Agency mission, and I'm also going to talk a little bit more about this because I've had some involvement in this mission too. And then looking forward to the 2030s, we're hoping to bring some samples back from Mars with the Mars Sample Return mission. So this is a collaboration between NASA and the European Space Agency. So the Perseverance rover, since it's been there when it landed in 2021, not only has it been doing its own science, it's also been collecting samples and putting them in these tubes and leaving them behind, like a Hansel and Gretel trail. So the idea is that we'll send another rover to go and collect these samples, and we'll launch those back into space and bring them back down to Earth to do some really cool science with. So the timeline for this is not as clear. We're hoping in the 2030s we'll have some real samples from Mars here on Earth for us to do some really cool science with. But a bit more detail about ESCAPADE. So ESCAPADE will be launching at some point this year. We don't have an exact window yet, but ESCAPADE stands for Escape and Plasma Acceleration and Dynamics Explorer. So we love an acronym in space. We like to shorten things as much as possible. So this is a mission that is a NASA mission. It's a NASA kind of small budget mission. So it's not as expensive as some of the other missions. But it's mainly being led out of UC Berkeley out in California. And this is a 2-satellite mission. So we have 2 satellites going, and they're both about the size of a mini fridge. And we'll be going to explore the plasma interaction with Mars. So I mentioned at the start that plasma is what makes up space. So if we think about the transition from solid, liquid to gas, you're adding heat, you're adding pressure to go from solid to a liquid and from liquid to a gas. If you continue to add that energy to a gas, you'll create something called a plasma, which are charged particles. Now, the sun is constantly emitting charged particles out into space, and it interacts with all of the planets in the solar system. And it's the reason why we get these fantastic features like aurora here on Earth. Now, these 2 satellites are going to investigate this interaction of plasma with Mars. And it's going to do this in 2 different ways. So it'll have 2 different orbit configurations. The first one will be this formation called a string of pearls. So one satellite will be behind the other, and they'll go through these different regions just with a bit of a time delay to look at how this very sensitive plasma system varies over time. And then the orbits will switch and they'll be perpendicular to each other. So they'll be observing different areas at different times to help us understand how plasma interacts with Mars. This is super exciting. I'm very honored to be on the science team for this. So hopefully looking forward to going to Florida to watch this launch at some point this year. The next mission I'm going to talk about that's coming up is the Rosalind Franklin rover. So the Rosalind Franklin rover is a European Space Agency mission that is due to launch in 2028. So you may have heard of this rover before because it's had multiple launch opportunities that have all been delayed for various reasons, but we're really looking forward for 2028. Now, this rover is going with the objective to look for signs of life on Mars. So it's aiming quite high, but I'm certain it can achieve it. Now, there's lots and lots of different instruments on board this rover, but the 2 I want to talk about are the camera, and hopefully you can see my mouse, but on the left-hand image, this white box at the top is the camera. This is called PanCam, which stands for Panoramic Camera, and this was built, designed, and is led by my colleagues at the Millard Space Science Laboratory. So I was lucky enough to see the clean rooms where they built this camera whilst I was doing my PhD. Now, this camera is not only going to take some beautiful photographs, but it's also been designed to put filters over these photographs so it can highlight different areas of Mars, particularly looking at different components of the atmosphere and different components of the geology. So just with images, we can do some really, really cool science to highlight the water-rich minerals on the surface, for example, or the clouds in the atmosphere. So you obviously need a camera, but why not do some really, really cool science with that camera? The other instrument I want to talk about is this black box on the right-hand image, and you can see at the bottom the start of the drill. So a lot of the science we can do with our rovers is taking samples from the surface and analysing them and seeing what they're made of, when different rocks were formed, what their compositions are, and what that might mean for the wider environment on the surface. Now, Perseverance, Curiosity, multiple of the rovers that have been there in the past are able to do this. But for context, the Perseverance rover can go between 6 and 7 centimeters down into the surface. Rosalind Franklin can go 2 meters. So we are going well below this threshold to sample areas that have never been sampled before, which sounds a bit like a movie title. But this is super exciting because we're going to be looking at areas of Mars that no one's looked at. So we're able to drill all the way down to 2 meters, bring these samples up, take photographs of the samples, and then take them to the inside of the rover where they can be analysed, and we can get some really neat science results. So Rosalind Franklin is hoping to go in 2028. The UK is not just involved in the camera, it's involved in a load of the other instruments, and the rover was actually assembled in Stevenage at Airbus. So the UK has had a lot to do with this rover, so we're all really looking forward to the launch in a few years. So to conclude, if you go all the way back to 2000 BC, where we first identified Mars as that red dot associated with the god of war, to now, our knowledge has really accelerated. And not just in the last 100 years, where we've gone from kind of very vague identifications with telescopes to really detailed global images with our satellites. But we still have so many more questions that we want to know, and so many more questions that us as scientists are desperate to find out. So how does the atmosphere, the ionosphere, which is the highest level of this atmosphere where we have charged particles, and the magnetosphere, where this plasma is, how do these three areas connect? Does that link to why it lost its magnetic field 4 billion years ago? How does this react to the solar wind and things that come from the sun out into the solar system? ESCAPADE is really going to help us answer these questions when it launches later this year. But that will also help us understand what's going on with the atmosphere. How has Mars ended up so dry and arid? What happened? How fast did it go? Is it still going? Will Mars have no atmosphere at some point? ESCAPADE will also be able to help us understand this. And Rosalind Franklin will be able to answer this from the surface as well, being able to look from the surface down to look for signs of water and for signs of life, because that's the real kind of golden ticket, is seeing if there ever was signs of life on Mars. So all of these missions, multiple of these missions, past, present, and future, have helped us gain an understanding towards these questions. But like any scientist will tell you, you go in with an idea of one question in your mind, and whilst you try and answer that one question, at least 10 more questions come up. So there's always something for us to do, always something for us to investigate. And that's why I absolutely love working on Mars and wouldn't change it for the world. I hope you enjoyed the presentation. Hopefully I stuck to time, and there'll be some time for questions as well. Thank you very much.
Thank you very much, Catherine. And if we could applaud on Zoom, we would. But I know that Zoom cuts out the sound, so it's a waste of time. But consider yourself having been applauded. That was a really inspiring talk. Thank you very much.